All right, this is our last part of what we did in our class today. We took a look at the z-score, and the z-score for us will be another way to measure the position. We took a look at the ages as our data set. So here are the ages that we have, and then I asked you, where do you think you stand relative to the class? So we took a look at box plots, and we kind of saw what if we split up ourselves into about 4 parts of the class. Are you going to be in the first quartile, the second quartile, third quartile, or in the last quartile? And then we took a look at how to measure your position that way. But another way to measure your position is to ask yourself, how many standard deviations away are you from the mean? So if you take your mean and then you find the standard deviation and then you move yourself this much, what is going to be your x value? So this is the formula that this bold-face kind of statement refers to, is that the x value is equal to the mean plus some standard deviation times some number. So that number z is often called your z-score. This is your score with respect to how many standard deviations you are from the mean. So if your z-score is +1, that means you're 1 standard deviation to the right of the mean, bigger than the mean. If your z-score is -2, that means you're 2 standard deviations away from the mean in the negative direction. So this is our x is equal to x bar plus z times your standard deviation. Now, if we solve for z, which is most likely what we're interested in doing, then z is going to be equal to this x minus x bar divided by s. So it's x minus the mean, all that divided by the standard deviation. And this is going to give you your z-score. Okay. Let's assume that we have our data set. These are our ages again that we have for our class. And we're interested in using this formula to create a column of z-scores here. And so what we need to do is we need to find our mean and our standard deviation. And so to do that, I'll say equals and then average. And I want to find the average, and here it's suggesting it goes from A2 to A25. So just to check, A25 is down here. I'll go ahead and agree to this. I'll hit tab. Then I get the mean, the average, or age average for this class is going to be 23.8. And I'll do a standard deviation the same way. I'll say equals STDEV. Open parentheses. It's giving me the same range, which is exactly what I want. So I'm going to go ahead and press tab to agree to that. So these are my values. Okay, now I want to find the z-score for 18. So if you're 18 years old, I can ask, how many standard deviations are you away from the mean? According to this, we have this formula. So I'll just say my z is going to equal to, I have a numerator that I'm subtracting, so I want to be careful and make sure I put the parentheses there. So I'll open with the parentheses. I'll have an 18, so this is the A2, that's the slot. I'll say minus. Now, instead of pressing this, I'm going to actually type it in. And I'm going to type in about 4 decimal places, so 2.8333. Okay. That is my numerator. And then I'm going to close the parentheses, and then I want to divide by the standard deviation. So divide by signal or symbol, and then my standard deviation is 8.5448. I'll go round up to 9 because it says 8.5 there. So that is my formula. I'm going to press enter. And then it's going to ask, oh, do I want to fill it in? I'll say yes, go ahead, because it looks like it's the correct formula that I want. And then it fills it in. So what do we have here? We have, in our age class, we have 18-year-olds are -0.6 standard deviations away from the mean, going on the left side. 19-year-olds are about half of that, so half a standard deviation to the left, it's about 0.5. It's 0.56 technically. Now the mean is 23, so somebody who's like 23 years old would be almost 0. So this is negative 0.09. You're a little bit less than the mean, but you're really close to the mean because you're almost 0. If you're exactly 23.8 years old, then you would be exactly 0 here. Okay, so anything that's bigger than 23.8 will have a positive z-value, z-score, because now you're on the right side. And then if we take a look at 33 and 34, you're about 1 standard deviation away from the mean. So if you imagine you add 23.8 plus 8.5, that's going to be like 30, 31, 32-ish. So that's like the 1 standard deviation away, 33 and 34. Now, usually if somebody is more than 2 standard deviations away to the left or to the right, we call that an outlier. So my z-score over here happens to be 3.88. So I'm way out there, and we are looking at 3.8 standard deviations away from the mean. So anything usually that's over 2 standard deviations away from the mean will be considered an outlier, or can be considered an outlier. And that's what we saw before when we were using the quartiles to measure a position. Here we're using the mean and standard deviation to measure a position, and then we see that this is in fact still an outlier for us. All right, so that is the quick story on the z-scores. Oh, we also took a look at the z-scores graphically. We have a number line here with an x, and we have a number line here with a z. And we can see that a z-score of -2, -1, 0, 1, 2 would be like most of the data set. And then this outlier, which is about 3.8 standard deviations away from the mean, is way out here. Okay, so there's a good way to see this, the relationship between the x data and then the z data, and then seeing that as a measure of position. All right, I hope that helps. Good luck.